Stage is yours.
Okay, great. Yeah, hi. So my name's Chris, and I'm here today to talk about tRPC, which is basically a new way of building APIs. I kind of like to set expectations when talking about something new. So in the case of tRPC, it doesn't let you do anything new user-facing. Like you can build the exact same apps as before. It doesn't improve performance. In fact, it might make it a bit worse. And is there a lot of static? Is the mic okay? Okay. And yeah, it's a non-starter for many projects. Yeah, it's a non-starter for many projects. So you need to be all TypeScript, and there's a couple of other requirements. But if you can use it, then you can build really fast. You can be really confident about refactoring. You don't lose time to dumb mistakes. And the main thing is you can just get stuff out really fast and have a lot of fun while doing it. A bit about me, I'm a designer turned teacher turned developer, and currently doing full stack with a focus on improving the DX at Moody's Analytics. So we use data to help companies negotiate risk. In my free time, I work on DevTools and DX. So I'm currently a contributor to tRPC, where my biggest project is writing new docs, because the current ones could use a bit of work. And I'm also a core maintainer of Create-T3 app, which is basically a command line tool that lets you initialize an app with Next.js, tRPC, and a couple of other things in like a modular way, where we take care of gluing everything for you, so you can just get started building your actual application. And yeah, this is my first Meetup talk, so excited to give it. I'm gonna be ad-libbing a lot, so it'd be good to know a bit about my audience. Raise your hand if you've used tRPC. One person, 2, 3. Raise your hand if you've used GraphQL. About half the room, 2/3. If you've used REST, everyone. I guess this is also going to be everyone. Built a front end that talks to an API. And if you've used React Query, about half, I'd say. Okay, so this is the big question. How should we build APIs, right? Everybody starts with REST. It's pretty good. It's a simple mental model. And then once in the front end, you add like caching and invalidation and all that stuff. Like it's a pretty good way to build an API. But there's also kind of a lot of frustrations that keep coming back. For example, has this ever happened to you that you lose an hour to some typo in some URL when you make a request? Have you ever come into a new code base that's built on REST and it's not that easy to find the API logic for some call from the front end, or the other way? You're in the backend and you try to figure out where is it being consumed in the front end. In this case, maybe you have a query, then there's a fetch function somewhere else, then you go into a different code base where the API lives, then you go into a router, and then finally you find a function. And do you remember if the ID on the previous slide was a string or a number? And what happens if you send the wrong type there? And yeah, the way you describe the way you write your backend, do you need to check for every possible thing that could be incorrect on the request, or do you just describe what a correct request looks like, and then it deals with everything else? And the last one is, have you ever broken something by changing something in the backend and forgetting to change one consumer in the front end? So we have solutions for this, right? Like GraphQL is really, really good. Like the concept of having a schema that's like the source of truth or the contract between your backend and the front end works extremely well. And like once you go type safe, and once you go to a point where your front end knows what your backend looks like you really can't go back. Like once you have that experience, you can't do like not type safe, no type safety across your network REST anymore. There's also OpenAPI, which is also really good, but I find it's more for like, if your company makes an API that some other company somewhere else is going to consume. But GraphQL, as good as it is, it's kind of rough in certain types of projects. So the biggest thing is that writing a schema, it gives you a lot, but it's also a lot of work. And then you have CodeGen, which is an extra build step, and the ecosystem is super complex. Like, do you use Urkel? Do you use Relay? Do you use Apollo? There's so many different things to think about. And I was finding that in a lot of projects, my data isn't very graph-like. So I was just using GraphQL basically to get type safety in something that works the same way as a REST API. And I thought, like, can we do better? So what the ideal thing would be, right, is like REST with all the best parts of GraphQL. So the front end knows the back end. You can share input validation logic. You don't need code gen. And ideally, you'd want it to work in full stack Next.js with React Query, because that's a really great way to build apps. So I thought I'd build that library. Spoiler, it didn't go very well. Turns out sharing types and sharing data validation is pretty easy, but getting to the point where your front end knows the shape of your backend is really, really hard. And I'm just not that much of a TypeScript wizard. And then I found tRPC, and it turns out they had already figured all of this out. So the first question I get from a lot of people is some variation of either how does it relate to gRPC or even what is RPC? And maybe you've seen this Elon Musk tweet. But basically, RPC is a way for a computer to call a function on a different computer. And that sounds kind of like REST, doesn't it? And yeah, it does. Like, that is basically what REST is. And the important part of tRPC isn't the RPC, but the T. And the T is type safety, specifically type safety across the wire. So the way it works is you define your backend as one big object, then you export a type from that backend and import that type in the front end. Then tRPC does some TypeScript magic, who knows? And suddenly React Query knows what your backend looks like. I'm about to go into showing some code, but first, there's a lot of vocabulary that I think the GraphQL people are going to be familiar with, but maybe to everybody else it might be new. So in tRPC land, the unit is kind of a procedure. So a procedure is basically just an API endpoint, and it can be either a query or a mutation. Query is get some data, so it's like a get request in REST. And mutation changes some data, so it's like a post, put, delete, and so on. A router is a collection of procedures, so every tRPC project starts with one super parent router, and then you can nest them the same way you nest folders and files. Context is stuff that every procedure has access to, and so usually what you might put in context is your database connection, the user session, stuff like that. Middleware is kind of the same as it is everywhere else. The big thing about tRPC is that your middleware, if it modifies the context, it passes it forward in a type-safe way, so the procedure knows what has been changed about the context. And finally, validation is just the answer to the question of, does this input data contain all the stuff that we want it to have? And I'm super glad I'm just showing code and not live coding, because I need to hold this mic.
Let me know if I should hold.
See how it goes. So the first thing we're going to look at is this simple app. And this thing here, if I refresh the page, you can see, for a second it flashes in. It comes in from an API. Yeah, actually, maybe.
Sure thing.
Let's see, how is this font size?
Can you make it bigger?
One bigger? Is that good?
Yeah.
Even one more if you have line width enough.
Yeah, seems okay. Oh God, the stuff in my editor is really small now. Right, so here we have a tRPC procedure. So this is a query. It's to the endpoint, it's the endpoint api.example.hello use query, and you give it some text, and then you get something back. And kind of the first point that I was saying about REST is that it can be kind of hard to figure out how your front end and your backend connect. In tRPC, what you do is you move your mouse over the word hello, and you hold command and you click, and now you're in the backend where it's defined. So you can see here we have the input, which is a string that needs to be at least 6 characters, and then we return a greeting based on the input text. Other stuff you can do here is, for example, we have autocomplete on the router because the front end knows what the entire backend looks like. So I can do console.2 is equal to API. And then in autocomplete, I have all of my subrouters. And here I have all of my procedures. And then it knows that this is a query. And then I also have type safety in the arguments. So here, the only thing I can give is text. So I'll do something like that. And now, for example, if instead of a string I give a number, I get a type error here. And same thing, for example, if I add an additional thing to the request, I get a type error because this can't exist. And it doesn't only go this way, it also goes the other way. So for example, if in the backend, I change what gets returned, so greeting will do this. Now in the front end, wherever this is being used, I'll get an error here that greeting doesn't exist on that type or on that procedure in the backend. And similarly, for example, if I was to change this name, then again here you immediately get the error. And this is really nice because in TypeScript you have a build step. So any way that your front end breaks the contract of your backend is going to be caught in CI. So it's pretty much impossible to ship an incorrect usage of the backend. We also have a couple of other things that are nice to show. Let's fix this quickly. So everything works through inference. There's no schema, nothing is defined, but occasionally you don't just need inference, you also need explicit types. So for that, we have the router inputs and router outputs. So I can do something like type foo is equal to router inputs. And here, again, I get autocomplete on what my API has. And now the type foo is the text that this API requires. So you have that for inputs and outputs. And that can be super useful, for example, if you need it for the props for a React component or something like that. Then there's another kind of nice way to look at it, which is if I open, oh God, these are really small. If I open the dev tools, and if I can, yeah, it's this one.
But you need even more for us as well, so you can.
So you probably can't see this, but I grab the URL for the request. Oh, and there's probably the word get in front of it in capital letters. 1, 2, 3, 4. Yeah, this I can make bigger. So the validation doesn't just work on the back end, it works everywhere. So for example, here, I can make this hello from TRPC request. Oh God, this is really hard as well. So here the backend gives us a Zod error, and I usually would say expecting string got a number. I think I missed a bracket or something there. Sorry, my screen is really small. You're gonna have to trust me. But the other way it works is in the front end. So I can go to this CRUD example. And again, with this thing, like the backend says a post needs to be at least 6 characters. So if I do this, I get an error here. Hey, it needs to be at least 6 because that's what I call the error. Usually you'd get a default one. And the nice thing here is we're not making any post requests. So this validation logic exists in the front end without having to define it separately. It's all just inferred from the backend. And the last thing I want to show is we also have TRPC panel. A guy named Isaac from the community made this. If you've ever used OpenAPI or GraphQL Playground, this is going to look really familiar. So you get automatic documentation on the entire shape of your backend the same way you would with Swagger or OpenAPI. And there's like a meta tag that you can put into each procedure so that you also get comments and any explanations you might want to give about the procedures. That's kind of all I wanted to show in terms of code, because like building an API works exactly the same way, except you just don't get frustrated as much. And yeah, we have a lot of other stuff. So easy optimistic UI updates because we use React Query. Everything else React Query has. We have really nice errors that connect to HTTP errors. Server-side rendering and static site generation is really easy, especially if you use it in Next.js. With testing, I don't know. I guess it's not really DI, but you can monkey patch anything into the context. So for example, if you want to test with a logged in user, you just pass a session that looks like a user session, or you just pass an object that looks like it. We have TRPC OpenAPI. So TRPC runs on a different protocol called JSON RPC. But with this extension, you can create OpenAPI definitions for it. And this is really new. We just got a library that wraps around mock service workers, so you can create API mocks like in a very nice declarative way instead of sort of having to write the actual URLs. It works with basically everything in the TypeScript ecosystem. The big thing is you need to be in either a mono repo or a full stack Next.js app. And at that point, you can have as many servers as you want and as many consumers as you want, and they can all consume each other. Just a quick word on performance. I was really shocked about this. Did you guys know that Express is growing faster than Fastify Next and Nest combined? Turns out it is. So Express is still fast enough for most people. TRPC is faster than Express, but slower than Fastify, which means, or TRPC specifically in Next.js is faster than Express, so it's going to be probably good enough for most projects. And this is kind of the big thing, like who is it for? It's for small teams that want to build something fast, but still kind of be able to refactor it in the future. And really the strength comes from not trying to compete like in this whole other area, in this something else part. Personally, I think, so the left 2/3 of the something else section, that's where GraphQL is really awesome. And then the right third, that's where Open API is really like a good way to build your stuff. And there's a couple of other similar projects that are like pursuing this type-safe REST/RPC thing. There's 3 that are kind of similar, so it's TS/REST, Zodios, and Remult. What they have in common is that you declare your API as a schema. So it's kind of like GraphQL, but you end up with a REST API. The difference with TRPC is you don't declare a schema, but like just the way you write your API is the schema kind of. Like everything just goes through inference. And there's also Blitz.js, which is really awesome. It started by Brandon, who does flight control. And the difference there is that Blitz tries to be a lot more. So it's a full Rails-like framework with like a CLI, and it does compiler stuff, and it has its own auth. And so if you really want to buy into the Blitz way, then that's a really awesome choice. The nice thing about TRPC is like it's just a way for your client and your server to talk to each other. So like you can bring your own database, you can bring your own auth. Yeah, the whole remainder of your app is up to you to build. And this means that people have been doing really awesome stuff with it. Like people are building Discord bots and all kinds of stuff with it. You're not a real project if not at least one FANG is using you. And I'm happy to report that Netflix is using TRPC for internal tools. Other kind of exciting companies that are using it are Stately, which makes XState, and they also do a lot of other awesome stuff. Cal.com is, I think, the biggest open source code base that you can reference that uses TRPC. They're basically a better version of Calendly and fully open source. If you've ever used a course from Matt Pocock or Kenzie Dodds or Dan Abramov, the site that those are on runs on TRPC, and there's a lot of other projects. We're just starting to kind of figure out who uses it because most people don't actually tell us. And this is kind of the big question that's in the room now, right? What about server components? So the answer is we're working on it. The React team and Next still haven't released their information about what mutations are going to look like. So we're kind of spelunking around the canary builds and like trying to figure out what they're going to do with it. And yeah, a lot is going to depend on that. But I think either way, we'll get it working. The big question is going to be like, are you building an app or a website or something kind of in the middle? And for the website category, we really don't have anything to offer. Like you just await your data in your component and it's there, and you shouldn't need to use anything else. If you're building like a super interactive app, then just keep writing everything client-side as you were before. But I think for kind of that middle ground, that's like where most projects are, right? Like they're a bit of a website, a bit of an app, maybe different parts are more website, different parts are more app. And I think TRPC is going to offer a lot there. There's this phrase that Ryan Carniato used that really stuck with me. It's the two application problem. And it comes from the old days when you'd write like something in PHP or Rails or something, and then you'd put some JavaScript in it. And like your Rails bit or your JavaScript bit were kind of two separate apps, even though they're the same app. And with server components as it stands right now, like people still want to use React query and client components. Like they still want caching and invalidation and all that. So you're going to get back to that point where like you have your React query way in your client components, and then you have a different way in your server components. And so like you're talking to your API in two different ways. And we have a couple of demos. We always need to pin every version of everything because like Vercel changes everything like in every version. But I think we're going to have something pretty good to offer there. And yeah, it's going to be kind of a wild west of competing patterns for a while. So quick is like saying, what if you can just write closures of server code inline in your client? Solid is saying, like, what if your whole client is just 20 kilobytes and then you don't need to care about the server, but we'll still do server? And like everyone is kind of coming at it from a different angle now. Yeah, the Blink people are like working with compilers to make it work. So it's kind of an exciting time to be around. And the main thing kind of we want to keep alive is the idea that your front end should know what your backend looks like. That's like the biggest thing. And yeah, talk to me afterwards if you want to nerd out about server components. If you scan this QR code, there's a bunch of like resources, videos. There's one with ViennaJS's very own Matchstäuber talking about TRPC and just a lot of other stuff. And otherwise, that's all I had. So I'm open to any questions. Yeah.
Hi, thank you for this amazing talk. It was very interesting. I have
Should we give a mic or should I repeat the question?
Just repeat the question. Hello? Yeah. 1, 2. Okay. Thank you so much for this interesting talk. I have it's 2 questions. The first one should be super simple. Does this require monorepo to actually work?
Yes, you need to get your types from the back into the front end somehow. So the best way to do that is a monorepo. If you're in Next.js, then of course you don't need a monorepo because it's just one app. But yeah.
Thank you. And the other one would be most of this presentation, and especially this one slide about third-party integrations, everything seems to revolve around React. About the query, which I know has support for other things also, and unstack the query thing. But a lot, exactly this slide.
Yeah.
Some seeing React, native, Next.js, and some third-party adapters. How confident can we be, because not all of us are into this React world, how confident can we be to use this when we're not into the React world? And you're saying that even you guys that you seem to be in this, things are changing so much, so fast for you. So if we are not the priority, let's say we're using Vue, then how confident can we be that we have the support that we need?
So specifically with Vue, there's really good news. There's a company called Sidebase, or the product is called Sidebase and the company is called something else, I'm not quite sure. But they've basically built like a whole starter template and like their whole own client. And it's run by people with money, basically, not just by some people committing to an open source repo. So with Vue, I think you can be quite confident that it's going to be around for a while. With Solid and SvelteKit, our integrations are really just open source repos built by people from the community. And these people are really passionate, but it is what it is. Like projects change and people move on. And a lot of stuff that was really relevant 10 years ago maybe isn't anymore. But I think the big thing is like people are very scared with like how it's moving now. But if you build an app now in one of the sort of things that work, like Nuxt or Next or any of these things, it's still going to be as good as it is now 5 years from now. There might be something better that you're jealous of, but there's always going to be, right? Like we're always going to try to find a new way of building things. I don't know if that fully answers your question. Yeah? So should we wait for the mic?
You made a comparison between Express and RPCs. Aren't they completely different things altogether? Doesn't the RPC actually gets processed in or something like that?
Yeah, so TRPC isn't a backend of its own. It lives inside of other backends. That could be Express, it could be Next, it could be Fastify. The comparison I was making was specifically TRPC inside of Next.js. The reason being that more than half of our users use it in Next.js currently. And that is about 2 times faster in kind of, the really pointless test of how fast can empty requests and responses be processed. But yeah, you're right. It's not entirely a fair comparison. It's just to kind of give like a benchmark of where it sits approximately.
One last.
About speed. Have you also compared with the native HTTP server from Node?
We probably have. I don't know that off the top of my head, but I would assume we're slower because we're pure overhead, right?
I just had one experience last week. I had to upload some images, and because RTPC only supports base
Yeah.
4, they get images roughly about 300 kilobytes native, so you get roughly double the size. And locally, it took 3 minutes for this amount, to get from the client on the same machine to the server. Replacing the same thing with an Express API natively, a couple of milliseconds for the same. Partly the size is half, but the 2 to 3 minutes is still looks like there's a lot of, let's say, checking and translation happening on client and server side to amount of this long time for the upload.
Yeah, so TRPC is currently not very good at sending like large blobs of arbitrary data over the wire. It's being worked on. However, kind of the official recommendation from the team there would be make one separate endpoint specifically for that when you need to send like a really big file. Or in the case of images, just put them in an S3 bucket. It's probably the better choice for most things. But yeah, it is like a legitimate, if you want to send files to your backend and you want to use TRPC, yeah, probably have just a different endpoint for that specific thing.
Thank you. If you have any more questions, you can reach out to Christopher on the break. We're gonna have now 5 minutes break, so you can use toilet, grab drink, whatever, and then we're gonna set up for the next talk.
And there's also desserts.
I have one eine weitere Frage, und zwar, wenn man sagt, einfache Sache hat wie
No, it's off. It's off. Unfortunately. Now the live audience hear you. They don't see a camera, but as long as you're up to you, as long as your audio is fine. Prefer.
Can we make the resolution smaller? Does that work?
Yes, but you have to do it from your side.
Yeah. Check. Just so it's.
Just again, it's probably on purpose, but this is what they see. If that was what you intended from your camera. That's on purpose. It's perfect. Cool.
It's on purpose. It's not what
No,
I
if
intended.
if you go to StreamYard, you can choose a different source, or we keep it this way.
That's what they see.
They see this plus this.
Okay. I don't know what this is.
We're just picking up your microphone from there, but I'll hide it. Good.
Okay.
You're good to go.
Cool. Hi, everyone. I'm so excited to be here and to share with you my talk on use AI like a developer. Today, I'm going to show you how you can use AI to build developer tools interactively. AI has been a hot topic for the past 2 years, and it's being used in many different areas, from healthcare to autonomous driving. But did you know that you can use AI to build developer tools too? That's right. AI can be incredibly powerful when it comes to developing and iterating on developer tools. In this talk, I'll cover the basics of AI and how it can help developers. I'll also talk about the process of building developer tools using AI and how AI can help streamline the process. Finally, I'll discuss how AI can be used to optimize existing developer tools, making them more efficient and powerful. So if you're interested in learning how to use AI to create powerful developer tools, then this talk is for you. I'm looking forward to sharing my knowledge and insights with you. Let's get started. Talking got a lot more easy recently. Hi, my name is Clemens. I'm the founder of DevCraft Academy, where we teach junior developers to become seniors in 6 months instead of years. Recently, I've been playing around a little bit with AI tools for developers. Who recognizes what that is? Okay, like around 10 people, I would say. For the others, that's the OpenAI API playground. So OpenAI, who are also the creators of ChatGPT, they've got an API that we can use as developers. And there's also this playground where we can actually enter prompts, and these prompts are just plain text. And in green, you can see what the API output was. So this was the context I was giving it. Then I also start typing something, and the response will just keep continuing whatever was in there before. So how can we use this for development? The most intuitive thing that you might also know from ChatGPT is that we tell it something like, write a React component which greets the participants of ViennaJS. There should be a blue primary headline and a joke about AI developer tools in a paragraph. And I'm starting a code block here, and I'm also starting with const because I want the component to be in a const and not in a function. So if I hit submit here, let's see what it does. Nothing.
To make it a little bit larger, can you like zoom in on that? Just so
I could try, but as soon as I switch the tabs, it will be smaller again, I would guess.
Okay. Command plus, maybe just press.
Dann die Auslösung noch runterschrauben.
Yeah, but I think it's more.
Oh, hold on, now I've got the good selector here. Maybe even more. How is that? Better? Cool.
Is your connection?
Do you want it even bigger?
Yes, please.
Maybe you can just all move closer.
Yeah.
Too hard.
Okay, it's even warning me now. Wow, that's large. Oh, that's wrong. Ah, that looks good. Okay, great. Then let's see if it works now. Let's hit submit. Okay, it's giving me a ViennaJS component. It's creating a div with an h1 of color blue with the text "Welcome to ViennaJS," and it tells us a joke. The jokes are always the best from AI. I can promise. We were going to see a few of them. What do you call an AI developer tool that doesn't work? A non-functioning AI. Nice, right? Okay, so that's like the first approach that we would choose when we want to generate code. But what's the problem here? This might give us a good boilerplate to start from, but if we've got a little bit a larger component and we want to refine it with a lot of details, we end up writing more natural language than we would actually end up writing code, and we would be much faster writing code. So what would be much nicer, in my opinion, would be to have some kind of concise language that the AI knows how to transform into a React component. And I would like to develop something like this with you now. So I've got a simple suggestion. I told OpenAI, in the following, I'll define the programming language ACT, because acting is better than reacting. Please compile this language by converting it to a React component following these rules. First rule, the top level statement defines the component name like component : All of its content is nested by 2 spaces. Content can also be nested within content. Second rule, a statement, P, whatever, should be converted to this HTML. Third rule, styles provided in curly braces, like section, and then in curly braces font weight bold, and then the content should be converted to an HTML section tag or React section component with font weight bold. And the joke component, most importantly, should render a paragraph with a joke about AI dev tools. And then I've got this ACT component here. I call it greeter, and I have an h1 with an ID of main headline and a few classes, hi ViennaJS, and a joke in color green. And let's see if this actually works. Yeah, I've learned that I always have to submit it twice. Why ever? Okay, cool. So looks like that worked. So it got the ID correct, it got the classes correct, it got the style correct, and it even provided us with another funny AI joke. But I mean, that's not a lot right now, right? There is no use of the component, and we could have just let it generate static HTML. That's pretty much what this is. So let's do something a little bit more useful, and I'll add 2 more rules here to let it accept props. So I tell a component should accept props. Can you see my mouse cursor actually? Yeah. A component should accept props as a list of comma-separated values. Example, component AB accepts the props A and B. And 6th rule, props can be passed to a component by invoking it like component, and then open a parentheses, A text, B42. Okay, and to test this, I have defined a Meetup name prop for our greeter component, and I made a main component which just mounts the greeter component and passes the Meetup name. Let's check if this works. Okay, we can see there are props already, and it's interpolating the props here in the headline, props Meetup name. I didn't even have to declare what is interpolation, how does actually interpolation work in my ACT language. It just kind of got this intuitively. And I've got my main component, which returns the greeter component and passes the Meetup name as a prop. So I'm pretty sure that this works. Do you want to try it? No, right? No, that's not right. we just assume that it works. But it's getting more excited, and then we can try it. Because it's still not interactive, right? We still can't do anything with it. We're just passing around props, but yeah, still not much better than before. So now for the cool stuff. I'm defining 2 more rules, and these rules are actually made for managing state. So I tell it rule number 7, state can be defined as @myState, which should get converted to, yeah, you know, this statement that we usually use. And rule number 8, an input can create a 2-way binding to state, like input, and then in brackets, my state, which should be converted into, yeah, an input, inserting the state into the value prop, and on change, it would, yeah, write the state with the value of the input. By the way, who doesn't know React here? Okay, just one person. Cool. You will learn it now. Okay, or you learn ACT, it's even better, actually. So our input is much larger now. We've got the h1, which we already know from before. We've got our joke, and we've got a section which uses an input with the feedback. Hold on, but I haven't defined the input. I haven't defined the state. Let's see if it still gets it. I also added a class here to see if the syntax works together, like the binding and the class syntax and the style syntax. And I added another component, feedback box. And what I do here is I pass children. So we can also see if it gets it intuitively that it should actually pass this nested interpolation as the children prop. Yeah, and we still have the main component. So let's see what it does with this input. Oh, it actually got that we are using a state feedback. Yeah, we've got our main headline. We've got another funny joke. We've got the feedback section, and we've got our 2-way binding here, where the feedback from up here is inserted, and the set feedback function is called, which we defined up here, with the input's value. And the class name also worked. And the style also worked. Yeah, here we call the feedback box. That looks wrong. Oh no, it's correct. Yeah, it's smarter than me. Because it mounts the feedback box in here, which, yeah, looks like everything is correct. The only thing I'm missing here, no, everything's here. Cool. Okay, that's complicated now. It's hard for me to understand, so I would really like to give this a try to see if it runs. Okay, we've got some, what's this called? Code pen. Some playground where I can just paste this in. So we're rendering the main components down here. Oh, and it already did something. So we can see, first thing and most importantly, there was no error. It's not always the case with AI tools. Like, I've tested this before, and it's like a 9 in 10 chance that it works. That's pretty high, but maybe not for a professional tool. So we've got our blue headline, we have the super funny joke, and we've got our inputs. And let's see if the 2-way binding also works. You are so hilarious. Yeah, and you can see it got interpolated down here in the feedback component. So actually, we've crafted a pretty complicated React component, or even more than one React component, just by using our nice little ACT language, which enabled us to define a whole component in a really concise way. Yeah. So what's our learning from this? AI is cool. It's really nice to play around with it. I would really encourage you to do that. It's not reliable, however. I mean, now it was. I was actually expecting it to fail because it usually happens when you give a demo. But yeah, where could you go from here? I mean, you could still add more features to it, like, I don't know, define a syntax for making a server requests and how to handle it, for handling errors, for adding a loading state, whatever. You could add syntax for using React context, or yeah, the sky is the limit what to do. And you could integrate this somehow into your coding tools, because it's an API. If I would open the network tab, you could see that it's just sending a request to the server and it gets back the response streamed. So you could integrate this also into your VS Code with a little plugin, or yeah, or whatever you would like to do. I just think that this is really the nicer way of using AI for coding, that you, as a developer, develop your own tools that make it easier for you to work every day and not just use natural language input, because yeah, that's a little bit wordy and it might not save you a lot of time. But if you invest like 10 minutes or 15 minutes to build something like this, then probably you're going to save a lot of time with it. Okay. So, in conclusion, AI can be used in a variety of ways, ranging from simple automation of tasks to more complex and powerful applications. All of these are within the reach of developers, and many tools are available to enable them to do so. I hope that this talk has helped you understand the potential for AI and how developers can take advantage of it. Thank you for your time and attention. Are there any questions?
We have one in the back.
Or maybe not. Maybe we switch.
Try this one.
Turn it off, turn it off.
I'll just talk really loud.
Go ahead.
Okay, so generated content, generated question. Can you give an example of an existing developer tool that has been significantly improved through the use of AI? And can you walk us through the specific ways in which AI has integrated in the tool to achieve those?
I got like half of the question, maybe.
So can you give an example of a developer tool that was already improved by AI?
And if you didn't get it, he was asking the AI to give you a question. So that's
Okay.
So it's basically two robots.
That's nifty.
talking.
An example of an AI code generator tool. Well, yeah, exactly. GitHub Copilot. I haven't used it. I was too greedy so far. I've got a ChatGPT Pro subscription. That's where all my money goes. And yeah. So I'm using ChatGPT to generate code. Who has used ChatGPT to generate code here? Most people. Did you do it out of curiosity, or did you really use it when you were kind of stuck and you needed an answer?
Actually, every day.
Every day. Nice.
More questions?
More questions?
If you're not asking because you don't want to speak up, we can bring the functional mic to you. No worries. Okay.
All
If
clear.
there's no more, I'm sure you can ask Clemens after the talk.
Sure.
Thanks again.
Thank you.